Welcome to my YouTube channel, A Brain Area of Civil.
Today I am going to solve Geotechnical Engineering 2 Assignment 5. The first question is, he has given pore pressure parameters in list A and state of the soil in list B. So now we need to have the better idea about which parameter, which pore water pressure parameter has which state of soil. Okay, now coming to, there are two pore pressure parameters, B and A. So B is equal to 0 for dry soil, B is equal to 1 for saturated soil. Okay, so by this he has given B1 for saturated soil. So this is this matching, and now A is equal to 0.5 to 1 for normally consolidated soil. So this is 2 for 4, and A greater than 1 for highly sensitive soil, that is this one, and A is equal to 0 to 0.5 for over consolidated soil, this one, and A less than 0 for heavily consolidated soil, heavily over consolidated soil. So this is the option. So answer B for question number 1. Okay. Next question. In a consolidated drained triaxial test, a specimen of saturated sand means cohesion C is equal to 0 under additional axial stress to 50 kN per meter square when the cell pressure was 100 kN per meter square. That is, minor principal stress is equal to cell pressure, sigma C is equal to sigma 3, that is equal to 100. And now sigma 1 is equal to sigma C plus sigma D. This is sigma C is 100, sigma D is equal to 250. So it will be 350 kilonewton per meter square. So now he asked us to calculate angle of internal friction. We know equation sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. So sigma 1 is equal to 350, sigma 3 is equal to 100 tan square alpha. So from here alpha is equal to 61.87 degrees. We know alpha is equal to 45 plus pi by 2. If we will get value of pi as 34 degrees. So answer C for question number 2. Now determine theoretical inclination of failure plane to the horizontal. So generally alpha is equal to 45 plus pi by 2. So that is 45 is the inclination plus pi is 34 divided by 2. You will get it is 62. Nearest value is 59. Clear? So that is theoretical inclination of failure plane is alpha. Okay. Next. A triaxial test when conducted in a soil mass yields sigma 1 by sigma 3 ratio, that is major to minor principal stress was 4 at failure. Which of the following will result? So we need to go, obviously he has not given much information. So let I am taking sigma 3 is equal to 100 and sigma 1 will become 400. Clear? So now I will check option A as C is equal to 20 and pi is equal to 23. We have one equation sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. So substitute on right side. If we will get left side, this option will become correct. So sigma 3 is, I am taking it is 100 and tan square alpha is equal to 45 plus pi by 2. So that is 45 plus 25 by 2. So you will get it is 71.5. Tan square 71.5 plus 2 into 20 tan 71.5. So that is equal to, we are not getting sigma 1 as 400. This option is wrong. Now check option B. C is equal to 0, pi is equal to 37. When pi is equal to 37, alpha is equal to 45 plus 37 divided by 2. It is 63.5. So substitute in the equation sigma 1 is equal to sigma 3 is 100 tan square 63.5 plus 2 into 20 into tan 63.5. You will get it is approximately 400. So that itself is sigma 1 now. Clear? So option B is correct for for question number 4. Coming to question number 5. A saturated clay that exhibits C dash is equal to 10 and phi dash is equal to 28 was sheared to a failure quickly. The values of sigma 1 dash is equal to 60, sigma 3 dash is equal to 10 and UF is equal to 20. Calculate the value of sigma 3 at failure. Sigma 3 at failure, sigma 3, he has given sigma 3 dash, that is he has given the stress values in terms of effective stress. We need to calculate total. So total is equal to effective plus pore water pressure. So effective sigma 3 is 10, pore water pressure is 20, 20 plus 10 is 30. Answer A for question number 5. Coming to question number 6, the inclination of failure plane in degrees. So that is alpha value we need to calculate, that is 45 plus pi by 2. So 45, pi he has given it is 28 degrees. So 28 divided by 2, it is 45 plus 14, it is 59 degrees. The option B for question number 6. Next, the effective normal stress on failure plane is, it's the most important question. You might get this formula in the strength of material, that is principal stresses and principal strains. Okay, whenever a stress element he has given, the stresses on the stress element are sigma x and sigma y. If the stress has to be calculated on certain inclination plane, the formula is sigma normal stress, effective normal stress is equal to sigma x cos square theta plus sigma y sin square theta. Here sigma x and sigma y are sigma 1 and sigma 3, that is sigma 1 cos square theta plus sigma 3 sin square theta. Sigma 1 is 60 cos square 59 degrees plus sigma 3 is 30 sin square 59 degrees. It will be 23.26. It's the most important concept. Actually, we will not get this types of problems in the soil mechanics or geotechnical. We will get this type of formula in soil strength of materials. Okay, so 23.26 is option C for question number 7. Now coming to question number 8. So he has given the information regarding consolidated undrained test. So a CU test was conducted on a soil sample with cell pressure, that is sigma C is equal to, sigma C is same as sigma 3, it is 100, and sigma 1 is equal to sigma C plus sigma D, that is 100 plus 60, it will be 160, and C dash he has given 0 and pi dash is equal to 30, and Cu dash 0 and pi u dash is equal to 13 degrees. Okay, now we need to calculate what will be the pore water pressure at failure. So we have an equation, sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Similarly, sigma 1 dash is equal to sigma 3 dash tan square alpha plus 2c dash tan alpha. So corresponding to this pi dash, alpha is equal to 30 by 2 plus 45. Here alpha is equal to 13 by 2 plus 45. So you will get it is sigma 1 dash is 160 minus u is equal to 100 minus u tan square, alpha is equal to 45 plus 13 by 2. In terms of effective I am using, okay, I need to use this values, plus 2 c dash is 0 into tan alpha. So when it is 0, everything will go 0. That is 160 minus u divided by 100 minus u is equal to tan square 45 plus 13 by 2. So the only unknown here it is u. So at failure u is equal to 70 kilonewton per meter square. So the answer D for question number 8. Now coming to question number 9, an unconfined compression test, that is UC test. Length is 100 mm and diameter is 50 mm. Fails under a load of P is equal to 150 kilonewton and strain epsilon A is equal to 10%. Calculate unconfined compressive strength of clay, that is QU is equal to P divided by final area. to calculate final area, there is a formula initial area minus 1 minus epsilon A. That is 150 kilonewton. A is equal to 1963.495. This 1963 you will get like A naught is equal to pi by 4. 50 square, it will be 1963.49 mm square. So minus 1 minus epsilon is 1 minus 0.1. So it will be 0.0687 Newton per mm square. He asked in Newton per centimeter square. That will be 6.87 Newton per centimeter square. Clear? So the answer is B for question number 9. Now coming to question number 10. So it is somewhat lengthy question. So given, I am writing, I am not reading the this information, but I am writing. So A is equal to 0.4. He has given. B is equal to 0.49. So now he has increased the depth of embankment or height of embankment from 5 meters to 8 meters. That is, when 5 meter embankment is there, so sigma 1 will become 16.2 into 5. It will be 81. And he has given the lateral pressure is half of the vertical pressure. That is, sigma 3 will become 81 by 2. It is 40.5. And now this 5 meter has been increased to 8 meters. That is, when 8 meter embankment is there, sigma 1 will become 16.2 into 8. That is 129.6. And sigma 3 will become half of that. It is 64.8. Here the change will be delta sigma 1 is equal to 129.6 minus 81. You will get it is 48.6. And delta sigma 3 is equal to 24.3. Clear? So we have a formula for B as well as A. B is equal to delta U1 divided by delta sigma 3. So that is 0.49. Okay. So B value he has given it is 0.49. We need to calculate delta U1 is equal to 0.49 into delta sigma 3 is 24.3. So it will be delta U1 is equal to 11.907. And he has given AB value as 0.4 into 0.49, that is equal to delta U2 by delta sigma 1 minus delta sigma 3. So that will be delta U2 will become 0.4 into 0.49 into 48.6 minus 11.907. So it will become delta sigma 3 is equal to 24.3. So you will get delta U2 as, so 0.4 into 0.49 into 48.6 minus 24.3. So you will get it is 4.7628. Clear? So he has asked the total change in pore water pressure. So delta U1 plus delta U2, that will be 11.9 plus 4.76. So it will be 16.7 something. So check the options. It is 16. So around 16.4 it will be answer A for question number 10. Okay. So now coming to next question. So if the value of P and Q is 300 kilonewton per meter square and 150 kilonewton per meter square respectively, what will be the value of sigma 1 and sigma 3? So there is a plot called PQ plot. P is on x-axis and Q is on y-axis. P is equal to sigma 1 plus sigma 3 by 2. Q is equal to sigma 1 minus sigma 3 by 2. So he has given P is equal to sigma 1 plus sigma 3 by 2, that is equal to 300. And Q is equal to sigma 1 minus sigma 3 by 2, that is equal to 150. So if you will solve these two equations, sigma 1 you will get it is 450, sigma 3 you will get it is 150. So the option A for question number 11. Now a shear test was conducted on a soil sample at failure. The ratio of sigma 1 plus sigma 3 by 2 and sigma 1 minus sigma 3 by 2 is unity. So which of the following test it will occur? Generally, in consolidated drain test, so slope of this stress path, it is Q. P is equal to sigma 1 plus sigma 3 by 2. Q is equal to sigma 1 minus sigma 3 by 2. Slope of this stress path is equal to 1. Okay, so the slope here it is sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 3 by 2 is equal to 1. So consolidated drained test. So option A for question number 12. And now there are two interlinking questions. A cylindrical specimen of soil failed under axial stress. So that is sigma 1 is equal to 110 kilonewton per meter square. In an unconfined compression stress. In unconfined compression stress, there is no lateral pressure. That is sigma 3 is equal to 0. The axial stress will become major principal stress. There is no minor principal stress. The failure plane making an angle 50 degrees. Failure plane making an angle 50 degrees means alpha is equal to 50 degrees. We know alpha is equal to 45 plus pi by 2. From this expression, pi is equal to 10 degrees. So, and tau is equal to C plus sigma tan phi. And sigma 1 is equal to sigma 3 tan square alpha plus 2C tan alpha. So, from this sigma 1 is equal to 110 and 2 into C and tan alpha is equal to tan 50. So, you will get C is equal to 46.15. So, that is option B for question number 13 and angle of internal friction is 10 degrees. Okay. So, finally, the thing is you need to solve all the assignments to face the NPTEL exam. So, kindly I request you, all the students, practice all the assignments and you can note it down in any notebook. Okay. Thank you.